HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 176, recorded live Thursday, August 20th, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott discusses NServiceBus with author and enterprise development expert Udi Dahan.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. Today I have the pleasure of sitting down with Udi Dahan, who is a enterprise consultant and an independent consultant who is known worldwide for making things happen in the enterprise, and he has got an open source application called NServiceBus. And I bump into Udi all over the world. I think I saw you in Norway a couple of months ago. You're in Norway again right now. Is that correct?
That's right. Just not in Oslo. I'm in Trondheim.
Yeah, and you must do a lot of traveling all over the world doing this kind of consulting.
Yeah, pretty much. That's what I do. Go to all sorts of places and help people with their applications, with their systems, making it scale, making it robust, all that fun stuff.
And on your blog, you call yourself the software simplest. It always seems like you write in such a clear way that you're always trying to strive for simplicity and clarity in everything that you do. And recently, NServiceBus came to my attention, and it was kind of an interesting thing because I used to work for a large financial services company, and recently one of my former coworkers said that they were working with you and with NServiceBus, and I had just seen you before, and we hadn't had a chance to hook up for a chat. So I started digging into this, and I think that this is really something interesting for the community to hear more about, because I don't think that everyone knows what a service bus is. And maybe we can start from the beginning, and you can explain what a service bus is at its lowest level.
Okay. Well, the enterprise service bus space is not especially developed in the Microsoft community, but it's been going strong now for a number of years in the Java side of the world. And one of the things that often confuses a lot of people when thinking about a service bus is that they have this picture of a large broker that all communication goes through it. And it turns out that the broker style and the bus style are actually very different from each other, if not complete opposites. So while most people, when they think of a service bus or they think of a broker, they have a picture of BizTalk in their mind. That's actually a very accurate representation of a broker. A bus is something else in that it is distributed inherently. There is no such thing as a centralized bus. A bus is inherently distributed. Mm-hmm. And the other thing that differentiates a bus from a broker is that, well, quite frankly, a bus isn't supposed to do very much. A bus is more about getting out of the way of the services that run on top of it, rather than doing, let's take an example of some very complicated content-based routing, like opening up the XML of a payload that goes through it, sifting through a bunch of fields and seeing if a given field is greater than 17, then routing it to the left, and if it's less than 17, routing it to the right. Mm-hmm. That's the kind of stuff that often a broker would do that a bus would not do. And what makes that interesting is that it leaves the responsibility for all the business logic at the service layer, so that we have to be a lot more conscientious about how we assign responsibility to the things on top of the bus. So that's about it in a nutshell.
So is a bus about separation of concerns? Is a bus about deciding that here's something that does know a lot about the intricacies of our larger business, but at the same time abstracts away the smaller entities within the business?
That's a good question. I'm not quite sure exactly how to answer that.
The reason that I ask is that it seems like whenever let me try to phrase this nicely. I'm trying to think about all the different things I've done in my life, and I don't want to pick on a particular company, but it seems like at some point you get to an organization that is large enough, that has enough systems talking to each other, that someone starts saying, time for a service bus. It's almost kind of like the Band-Aid that they put on the cancer of the larger organization. That might be overstating it, but the idea that they have systems that are varied and complex but need to talk to each other. Maybe in the past they were tightly coupled, but now they're looking for a way to really separate the System A needs to talk to System B with other concerns. So I'm trying to understand what the bus is concerned with. Is it just simply a router? Where does the logic live? And is this a large company problem only?
Okay. So I'll actually come back to that separation of concerns that you mentioned, and create a slight differentiation between what's known as enterprise application integration (EAI), which looks very much as how you described it. We have an existing set of applications and systems that we've been having some pain integrating with each other, and what we're looking for is a way to ease that pain. And EAI was or had its heyday, and that's pretty much done. And now we're all doing SOA. The separation of concerns that the bus is looking to bring that wasn't so much there with the EAI brokers is that we're less focused on the applications as they are and more focused on the business responsibilities above that. So the first thing that we're trying to achieve is separation of concerns at a business level, and then use a bus to conceptually hook those up. And at a lower level, look at how the pre-existing applications map to those higher-level services. So I know it sounds a little bit abstract, but a lot of the problems that we've been seeing with integration are often a function of taking a tightly coupled business domain, something that the business views as always needing to be consistent, and shoving a service bus in the middle, or shoving a broker in the middle of that. So it's very important to get the boundaries right and have them lining up both technical and business-wise.
So how does sending messages with the entity that you send to the bus, how does that different? How does sending messages at the enterprise level, at the company level, differ from sending events and responding to events at the local application level? I'm
not sure that I'd say that they're that different in terms of mechanics. In both cases, you are sending a message. It's more an issue of intent. So when you're going to publish an event, to have that event actually have a certain business meaning. For example, order canceled. Order canceled is both a business event and can be represented as a message in its own right. So, something that would not be a good fit for an event would be something like cancel order request. And a lot of times the difficulties that people run into when using a service bus is doing request-response patterns on top of a publish-subscribe infrastructure. Then we're confusing the language that we're using, and that often makes routing quite a bit more difficult, and makes the whole who subscribes to who seem a little bit out of whack. It would seem quite unusual for a server to subscribe to a client, especially if we have a lot of clients. So a lot of the mix-ups and the difficulties that people have when trying to employ a service bus are due to not understanding the concepts behind it. That when you're going to publish something, this should be an event that has meaning in the business domain rather than being a request. So not everything needs to be pub/sub. You can still do request response over a service bus, just don't use its publish API.
Okay, so that sounds like there's a not too subtle difference between publishing a message and sending a message.
Correct.
Okay, so trying to reconcile the things that people might be familiar with in the sense of I have a system that wants to talk, WCF and have an endpoint to endpoint discussion versus, what we call pub sub, which can be, can be a pattern that can be very local or that can be very, very distributed. And then you use the term routing, and I'm familiar, we're familiar with that in the context of send something to a trusted intermediary that knows a little bit more and maybe can handle some addressing, and then might say, I'll give it to my friend, and my friend will give it to Udi, which is, still effectively point to point, although my friend could route to a different person if they needed to. What kind of things does the business logic in our applications know and handle versus responsibilities of the bus? Like you had made the comment about route it to the left if it's above 17 and right if it's below. Does the bus have, really internal knowledge about the system that it could make such a decision? Is that business logic?
It's exactly the opposite. Brokers are the kind of technologies or patterns that would do that kind of decision making about routed to the left or routed to the right. Buses don't and shouldn't do that.
So a bus would never do anything like that. It would never know about internals.
Right. It shouldn't need to know about internals.
Okay.
It's the responsibility of the system on top of it to handle those kinds of things itself, to structure itself correctly.
Okay.
But getting to maybe the difference between where you'd use a service bus and the way that a lot of people think about using WCF, the difference is more along the lines of when people think about using WCF, they think about using it between their client tier and their server tier, and as a communications technology. Whereas when you're looking at the layers of a classical application, you often wouldn't insert a service bus between layers. Okay, and that sounds a little bit odd, and I'll explain in just a second where you'd put it. Think about taking those layers and slicing it like a cake down the middle. All right? Now, those two pieces, in essence, you've got two applications now, each one with its own layers. You'd be looking at in what way does my business decompose so that I could really have two discrete apps. So if we think of, say, a classical e-commerce example, the part of accepting orders being and seeing that they're valid and all that selling portion could be viewed as one part of the app, and the part dealing with inventory management and purchasing new items and ordering them and managing where they are in the warehouse has another discrete chunk where there's an explicit event that passes data from one to the other. So the order acceptance event is something that the order side of the app can make the decision to do by itself. It would then publish that event using a service bus to the other side, at which point the inventory side of our application would do its inventory management and say, okay, well, now we see that someone's ordered 50 widgets, now we need to get them out of the warehouse and ship them to the consumer. So that's really the place where we'd look at introducing a service bus, not so much between a client and a server, but rather between two different business parts.
I see.
Where each one can have its own UI focused on its own little thing. So you don't necessarily need to view this as I'm building a gigantic app for investment banking and needs to be super high performance. I'm going to need to get a service bus. But even for smaller apps that are more locally focused, it helps me to, instead of having one large monolithic app, I can look at having several smaller apps, each one focused on its own domain, that tell each other about interesting occurrences via this bus. So we got our little order domain that's accepting orders, and our inventory management that's keeping track of stock. We've got our billing domain that's charging customers, and our little CRM part that's saying, wow, this person's really buying a lot from us. Maybe maybe we should say that this person is a preferred customer. That's an event. And the guys from the ordering part say, wow, we've got a preferred customer. Let's give him a discount. So it's more about describing the business activities that are going on and the business events, and then representing those as messages that get passed around on a service bus.
Okay, so this means that I could have this bus be something I use inside of a single process, just for organization of my system. I could have a single console application, and I could bring this bus up and have it all happen in memory. Or I could do a larger system and have it run on have the bus manage its work in a queue. Is that correct?
It could be in a LAN environment. It could be in a single data center across multiple data centers. Really, it's just a function of which technologies we put underneath or inside the bus. But it doesn't change conceptually what the events are that we're publishing.
I see.
That's really the value of the service bus, is that it helps us focus on our business logic and on the ways that it can be broken down into smaller chunks. And that helps us manage a lot of the complexity in the application as it grows over time.
Mm-hmm.
We often have the scenario, the system started simple, but it grew into this huge ungainly mess. How did that ever happen? And it's often because we didn't know to look for those places where we could start introducing some events. So in that sense, a service bus is actually very practical in helping us keep our systems maintainable and loosely coupled.
Hey everybody, this is Scott coming at you from another place and time. No doubt you probably bump into testing tasks now and then in your work. And you know, writing functional tests is probably not your favorite thing. It's kind of difficult, takes time, and the results can be dubious. Well, get ready to start liking tests thanks to Telerik with the new WebEye testing framework. Building web automation tests is a breeze. You've got code automation with advanced ASP.NET Ajax and Silverlight applications. You can write a single test, have it executed against multiple browsers at once. You benefit from a rich API. There's link support, integration with Visual Studio unit testing, also NUnit, XUnit, and MBUnit. Not to mention the free wrappers for Telerik RAD controls for ASP.NET Ajax and Silverlight, all shipping with Telerik's new testing tool. One of the best features, the WebEye testing framework, which is developed by Art of Test, is it's absolutely free. If you've already got hooked on WebEye testing framework, start using it right away. Go to Telerik.com for more info. Thanks a lot. This gives me the sense that if a service bus is not something that someone would take lightly, in the sense that would it be difficult to take an existing application and add a service bus to it, or should a service bus be part of a larger, for lack of a better word, more clever architecture?
I've been working with companies for a number of years on this exact kind of work, and often introducing a service bus is something that we look at doing first and foremost around the edges. So less along the lines of how do we break up our app, but when we need to integrate with some other system or with some other partner, say, instead of calling each other and creating more coupling, what events could we publish just around the edges, saying what happened inside our app? Sometimes the way that we go about doing that is by writing a trigger in the database and saying, when a row's been added to this table, publish. And then whoever wants to listen to that can hook into that. So it's often a good first step towards integrating our system into a larger ecosystem. So that's one way that we could look at introducing the service bus without worrying too much about the way our system is currently built, and doing that sort of in a step-by-step fashion. So you don't have to refactor your app and break it up into a million different little pieces. So I'm not sure that I'd say that it's something that you take lightly, but if you're looking at the long-term maintainability and integration of your system with other systems and providing more business value on top of that, I do see it having some kind of service bus or having the facility of being able to publish events being very useful.
How often do you find yourself where you're using WCF, Windows Communication Foundation, and Windows Workflow, and the Microsoft applications that start kind of getting in this general space? I mean, how much does NServiceBus fill a gap where Microsoft has kind of completely dropped the ball? And how do you feel about things that Microsoft might be coming out with, and where ServiceBus would fit into that?
Okay, well, NServiceBus specifically is not meant to replace WCF or to replace synchronous communication. NServiceBus does not do synchronous communication. Mm-hmm. That is what makes it do publish subscribe well, because it focuses on doing one thing very well. WCF, on the other hand, does not do publish subscribe. You don't have a WCF.publish out of the box. Mm-hmm. You can try to implement that kind of thing with callback contracts and some sort of routing endpoint that you set up, and even the stuff that's coming out in .NET 4.0 with the Dublin technologies and the Windows Server technologies. There still is no publish-subscribe facility that comes with WCF. Mm-hmm. So in that respect, in a given classical Microsoft app, you'd continue to use WCF for your client-to-server communication, and you may find the use for NServiceBus in doing your publish-subscribe communication. So you'd end up using both.
So it really is complementary. It's not something that Microsoft, does Microsoft have a service bus lying around that or lying in wait? Do you know?
Well, there is the .NET Service Bus and what was known for a while as the Internet Service Bus, mm-hmm. Which are primarily technologies for, in essence, doing WCF full duplex over the Internet. Mm-hmm. But even there, you don't have publish-subscribe functionality.
Right.
You do have a starting point as a part of the Azure technologies with the queue service that's out there. Okay. So in other words, you'd have a queue in the cloud similar to how you have MSMQ in Windows. So having a queue is a very useful thing, and NServiceBus makes use of MSMQ and queues in general. But when we look at that publish-subscribe functionality, again, more in terms of discretely representing events rather than any kind of communication, I just haven't seen that working out so well, especially if we're looking for something that we want it to be both lightweight in process and not just over the Internet or within our private LAN. So even though there is the service bus as a part of Azure, it's targeted at solving a different problem, which is that Internet relay communication. And Service Bus, the way that it's currently built, is focused primarily on in the LAN. So you've got a bunch of apps that are already physically together, and you just want to introduce some logical hub-sub communication.
Now, when I'm moving things around the Internet, inevitably things will turn into angle brackets, and there's messages that I have to deal with versioning. And typically I deal with versioning and with XML namespaces. When we're doing something in NServiceBus and we're dealing with versioning, are we talking about CLR types? And if I have two applications that are going to talk to each other, what is the thing they're collaborating over? Is it a CLR interface? Is it something else? How much do they have to know about each other? They both know about the bus. What do they have to know about the message?
Well, the message, first and foremost, is just like in any communication. It's your schema. It's the language that you use to communicate. And first of all, there's the logical representation of that, which is like we do with regular .NET and web services, things like that. We can represent them as regular classes. Then the question of when we want to move them over the wire, how do we want to serialize them? We can do binary serialization. We can do XML serialization. It's the same thing with NServiceBus. How you choose to serialize your plain old CLR messages is pretty much up to you. So that's more in terms of the representation on the wire. And while that's related to how we version things, that's not the entire story of versioning. It turns out that versioning is a slightly more complicated problem than just angle brackets by themselves can solve. Part of the things that makes versioning a little bit easier when thinking about publish-subscribe is that you've got explicit ownership of the schema. So, for example, in that e-commerce example, our order service is it's the only one that gets to define and to version what an order accepted event looks like. In a web services world where we have callers and callees, and that those callers can call others in turn, pretty much any web service can use any structure that they want, and it's harder to pin down who owns this and who gets to version this.
Right, exactly.
So that model of thinking, of saying, no, you own this, so it's your responsibility to version it. And not only that, if it's your responsibility to version it, it's your responsibility to version it in a backwards compatible way. So once you have that throat to choke, everybody tends to play along quite a bit better than in a classical web service style of approach where everybody can say, no, it's not me, it's him. No, I changed my web service, but he didn't change his web service. And you can never really say the buck stops here, because anybody can call anybody in web services. With publish-subscribe, there is only one publisher there's only one logical publisher for a given kind of event, and they're responsible for that. So that's more let's call it the organizational aspect of versioning. The technical aspect of versioning that NServiceBus does something quite interesting with is that it allows you to define messages as interfaces only, and not just as classes. Now, the nice thing about interfaces is that you've got multiple inheritance for interfaces, and you don't have them for classes. But when we think about messages or events, there's absolutely no reason that we would stop ourselves from saying, I have a new event, which means both event A and event B occurred. In other words, I want to represent an is-a relationship between one new event and two pre-existing events. What that means is that when I publish this new event, all previous subscribers of event A will receive it, and all previous subscribers of event B will receive it as well. In other words, I don't create a routing problem saying, well, you have to inherit from only one, and then you're going to have to do composition for the other, which means you're going to need a content-based router to open up that message, take out the composed part, and route it to the previous subscribers. So the fact that we can use interfaces in order to describe messages, in order to describe events, helps us prevent a lot of versioning problems and routing problems, especially as the system grows and we want to represent more complex relationships.
Very cool. Very cool. Yeah, the composition of messages as well as identity has always been challenging, and that the interface inheritance does have kind of an elegant way of both handling composition and kind of tagging a message with information. Can you annotate these messages? Can you add metadata like in the form of attributes, or would that be inappropriate?
The data is just the properties in the interface. So if you want to define an additional property, just define an additional property. Though I'm guessing that in terms of annotation, I'm thinking you're meaning something else.
Well, I mean, hints that aren't necessarily part of the business process, maybe. When I think of an attribute of something, I always describe it as a post-it note, which is like something that's maybe outside the usual running of the business. When someone hands you a whatever request on a piece of paper, that is a form that they've all agreed on, and then they might add a post-it note that is some additional bit of information that might be required.
Okay. So the way that you do that with NServiceBus is using headers, because what you've defined is that this post-it note is not an inherent part of the structure of this interface. It's something that I may put on, I may not put on, I may put it on a bunch of instances of messages. So when you're sending a message or when you're publishing a message, you can add headers, regular string value pairs, and put whatever you want in there. And obviously that something needs to be on the other side to look at those headers and decide what to do with them. But that's the facility that you'd use in order to do your post-it notes.
Mm-hmm. One of the questions I wanted to ask was, when you have really, really large systems, like when you put NServiceBus into a much larger system, I can visualize the distribution of the messages within a single process. But when you have 40 or 50 machines, what's doing the distribution part of the messages, and how does that work? I mean, machines go up, machines go down. You've got a large number of machines in a farm. Things happen in the more systems that you have. How is the robustness handled, and how is the distribution handled of the messages?
Okay, so the transport that's used for machine-to-machine communication in NServiceBus, or let's say that the strongest one that comes out of the box, though there is the ability to plug in others instead, is the MSMQ-based transport. MSMQ, and just like WCF uses MSMQ for durable messaging, and NServiceBus uses MSMQ for durable messaging. So that's the way that we handle scenarios where one machine is trying to send a message to another, and that machine is down. What happens at the MSMQ level is just that message waits on the sending machine until the target machine comes back up again. But this doesn't block the process that asks to send the message. So that's in terms of the physical moving the message from one machine to another under all sorts of failure scenarios. When we want to talk about robustness in a broader system perspective, then we have to start connecting messaging and transactions and business logic together. So let's say that we had a scenario where someone published an event that said order accepted, and we're the billing service, and that message that we're subscribed to appears in our queue, and we start processing it. So we take the message out of the queue, we start running some business logic, we go write some data to the database, and then our machine crashes. This can happen no matter what we're doing, whether we're using NServiceBus or not. The thing that we'd like to have happen is that, the database is smart. It knows to roll back if we didn't commit our transaction. And when our machine comes back up again, the database is going to be in a consistent state. However, what tends to happen, specifically if you're using HTTP, is that, the order accepted event disappeared. You forgot about it because you crashed.
Mm-hmm.
However, when you use MSMQ and the transaction that you're using, it spans both the queue and your database processing, as well as the sending of additional messages, you've got a much broader perspective of unit of work. In other words, we need to make sure that we were able to both write everything that we needed to the database. We have finished all our processing in terms of sending additional messages, and only then will the original message also disappear. So that way, no matter what crashes at which point in time, nothing ever gets inconsistent. But this is a core piece of functionality that making sure you do this the right way, and there are all sorts of scenarios that you have to take care of as well, that include things like, well, if we have a message that we can't deserialize, that always causes an exception. We don't want to get stuck retrying that message forever. So poison message handling, being able to detect the number of times that we failed processing a given message and then moving that to some different queue is also a core capability that's in NServiceBus. So that's how we maintain robustness and reliability at the single node level, which makes sure that we maintain consistency at the global level between all the machines in our service and with all our partners. Trying to do this kind of stuff over HTTP with classical web services, well, really the only way that you can do that is by flowing WS atomic transaction everywhere. But that makes everything slow as hell.
And yeah, and certainly what I've read about NServiceBus, slow is not a problem that you have.
Not really. The NServiceBus as a transport, with all the transactions and durable and XML serialization, things like that, it can fairly easily do per process, per machine, hundreds up to the level of maybe 1,000 durable transactional messages a second. But it's more in terms of when you design a system according to these principles, then you are able to scale out and achieve these benefits in parallel. So having 2 machines, that would be 2,000 messages a second. Having 10 machines, that's 10,000 messages a second. Whereas with classical web services, we just end up having more machines waiting for a response from each other. Whereas with NServiceBus, because all the communication is non-blocking, you don't get into those problems to begin with.
So folks can go to nservicebus.com to read the documentation and to get the downloads and stuff. Are there what are books or talks that you can recommend that people can read to start familiarizing themselves with service buses and how they fit into the ecosystem?
Well, I've been talking about and writing about these patterns for a good long time, so people can always go to my blog. That's udidahan.com and read up all the stuff that I've written over the years. Also, recently I was here in Norway giving talks about how these patterns can be used in building scalable web systems, and those talks are now recorded and online, so you can take a look at those as well. Those would probably be the 2 best, most immediate resources to go to.
Very cool. Well, thanks a lot for sitting down with me today and explaining ServiceBus and NServiceBus. And hopefully I'll get you on the show again to share some more of your wisdom with us.
All right. Thanks a lot, Scott.
All right. This has been another episode of Hansel Minutes, and I'll see you again next week.